blue marble photograph is considered to be one of the most widely shared photographs in existence. The photo taken during the Apollo 17 mission is one of the few photos ever taken that show the Earth in its entirety as a sphere where it is fully illuminated. This view reminded the astronauts of a blue marble, hence the name of the photograph. Since the Apollo missions were scheduled down to the minute and this photo was not scheduled to be taken, it is likely that this picture was taken hastily in the moment. The photo is credited to the entire Apollo 17 crew, Gene Cernan, Ronald Evans, and Harrison Schmitt, although further investigation into the photograph suggests that Harrison Schmitt was the actual photographer. The photo really puts our problems as a species into perspective. We really are just one species on one planet who create artificial boundaries and pretend that we're very different from each other when we're really just the same. On September 17, 1997, NASA launched the Voyager 1 spacecraft. The primary mission of Voyager was to study the outer solar system. But after completing its mission, it was destined to be the first man-made object to make it into interstellar space. On February 14, 1990, Voyager 1 was instructed to turn around and point its cameras towards Earth. The spacecraft then took the famous pale blue dot photo. This was the last photo the spacecraft took before its cameras were decommissioned. The photo was taken at the request of Carl Sagan, who thought it would be fitting for the spacecraft's last photograph to be one of Earth. The photo was taken at 3.7 billion miles away. At this distance, Earth only occupies 12% of a single pixel. Closer analysis of the photo shows that you can also discern the moon, but it only appears as a little smudge next to Earth. The true scale of the universe is very hard to put into perspective. In fact, it's essentially impossible. But photographs like this help us gain a little bit of perspective into how massive the universe is. NASA engineers designed the Hubble Space Telescope to photograph the most distant and oldest objects in the universe. Images of distant galaxies are also images of the past, since light takes an enormous amount of time to travel those extreme distances. The most distant galaxies ever imaged were imaged by Hubble in 1993 after its first repair. These images are known as the deep field and ultra deep field images. These photos were taken in an empty region of space, devoid of interference from our own galaxy. In order to take these photographs, Hubble had to take over 800 exposures over the course of 11.5 days. The oldest galaxies in the image are 13 billion years old. They formed only 800 million years after the Big Bang. Since the light has been traveling for so long, it has been redshifted to the near-infrared spectrum. Light is redshifted due to the Doppler effect, and the farther away an object is, the more redshifted it becomes. Hubble's successor, the James Webb Telescope, is designed to detect more infrared light. This will allow the James Webb Telescope to study the earliest and most distant galaxies in the observable universe. When I first saw this image of a black hole, I chalked it up as being insignificant. I thought it was an overhyped scientific discovery that was cool, but not very consequential. I could not have been farther from the truth. This image is in fact one of the most important images of space ever taken. To understand the significance of this photo, you first have to understand the scale. This video shows the insane scale of this image. Besides being very far away and being very small, the black hole was also surrounded by a cloud of material. This made it even more difficult to photograph. The photo took a planet-sized array of radio telescopes to picture. The logistics of taking this image were incredibly complicated. Not only did we stretch the limits of our current technology, it also required international cooperation. The shape of the black hole was modeled beforehand using Einstein's theory of general relativity. This further proves that theory. The data collected during this effort also helped scientists determine how galaxies form, how matter is devoured in the center of a galaxy, and how matter interacts around a black hole. Robert Wilson and Arno Penzias were two American radio astronomers who had an issue where they would pick up a buzzing noise on their horn antenna from all parts of the sky. What the duo thought was radio interference was actually the most direct evidence of the Big Bang. What they were picking up on their radio antenna was the cosmic background microwave radiation, or CMB for short. Right after the Big Bang, the universe was a very hot and dense place, filled with hydrogen plasma. This was known as the Hadron Epoch. All photons from this epoch would scatter immediately, making the universe dark. As the universe aged and expanded, it started to cool, and at about around 370,000 years after the Big Bang occurred, the universe cooled enough to become transparent. The photons released from this time make up the CMB. The CMB helps scientists determine the age and composition of the universe. It also provides evidence for the Big Bang theory. The CMB is the oldest picture of the universe we can get. The fact that humans can detect such a thing and understand it is a representation of how intelligent our species really is.